Okay, solving for angles in trig equations. Okay, example 1. Sine of the angle equals 0.386. Alright, step 1. Get the quadrants. Okay, so remember the astica that we did before? We are determining which quadrants is sine a positive trig value. So sine is positive in here and here, quadrants 1 and 2. Step 2, find the reference angle. Okay, so to find an angle, you remember finding an angle means inversing. So we're going to go second sine of 0.386. So that means getting your calculator out. Second sine 0.386 equals 22.7 degrees. Step 3, find angles, so your actual answer. So the reference angle means that's the distance to the closest x-axis. So where does this angle actually end up in the 0 to 360 mark? So this would be 22.7 degrees bigger than 0. So if I add that to 0, I end up at 22.7 degrees. Where does this angle end up being positioned? Well, this line that it's connected to is 180, and we're 22.7 smaller than 180. So I would be going 180 take away 22.7, and that ends up being 157.3 degrees. Okay, and we talked a little bit about this in the ambiguous triangle, because remember, solving for sine, you could have two angles, and so these are the supplementaries of each other, right? You can always check your answer. So checking your answer on a test would look like this. What is the sine of 22.7? I should get 0.386. What is the sine of 157.3? 0.386. Okay, so now you know you are right. Number 2. This time we have cos of my angle is negative 0.6428. Okay, step 1, find the quadrants. We got astica. So cos is negative. So therefore I'm in quadrant 2 and 3. Okay, everybody sees that? Because we're positive here and here. So we're going to do the other ones. Okay, step 2 is tricky. We're going to have to remember a rule. When you find the reference angle, you want to, whatever function you're doing, I'm not sure what function you'll be doing, but no matter what, you're always going to type in a positive number to get the reference angle. So in this case, I want to go like this into my calculator. Cos inverse, and instead of the negative, I want to do that. Okay, so I'm going to cos inverse 0.6428. Okay, we're going to go rounding, because I'm going to go to one decimal place. That makes that 50 degrees. So that means the distance from the closest x-axis is 50. Step 3, find your actual position of your angles. This one is 50 degrees smaller than 180. Okay, and this one is 50 degrees larger than 180. So 180 plus 50. Okay, and again, you can check your answers. For instance, let's check 230. Cos of 230 equals, there you go. Going back to this one, what if you had typed in cos inverse of negative? 130 degrees. Remember when we talk about getting your reference angle? Is that an acute angle? No, that's obtuse. So therefore, yes, you're like, oh, but I got the answer. Okay, but this is going to mess you up because it's going to put you in a different quadrant if you're dealing with that as a reference angle. Sometimes when you do these with a negative, it also might give you a negative angle. Okay, so that's what kinds of mistakes you could run into. Okay, example 3, let's do one more. I'm going to give you a negative. Tan of the angle is negative 0.364. Okay, Astica. All soup turns cold. Tan is negative here and here. And there's my x-axis connection. Okay, so we're tan inversing, remember, positive. Tan inverse positive 0.364, you should get 20 degrees. Therefore, this angle is 20 degrees smaller than 180, and this angle is 20 degrees smaller than 360. Okay, so that's how I would calculate that one. And you can always check your answer. Let's check 340. Tan of 340 equals negative 0.364. Okay, let's just do a fun test here. How would we have gone wrong if we had inversed the negative? And that one would have given you a negative 20 angle. So not a reference angle because it has to be positive and acute. Okay, let's continue. Now we're going to amp it up a notch here. 2 sine of angle plus 4 equals 5. Okay, we're adding a step right away. Now we have to isolate our variable. So algebraic skills, get rid of 4. 2 sine angle equals 1. Get rid of the 2. Divide by 2. Sine of my angle is a half or 0.5, whatever you like to do there. Okay, Astica. Sine is positive, so that is in quadrants 1 and 2. Here's my x-axis. Sine inverse of a half is 30 degrees. So where do these angles end up in a position? So from here it's 0 and you're bigger than 0 by 30 degrees. Here from 180 you're smaller by 30 degrees. Okay, and you can still check these. Ready? 2 times sine of, and I'm just going to use one of my answers here, 150 plus 4, and it should equal 5, and it does. Okay, harder example number 2. 7 cos angle plus 4 equals 4 cos angle plus 3. Okay, algebraic skills. We must collect the coses together. That's our variable. So I'm going to, I like to always get rid of where there's fewer of them. So those cancel. This is 3 cos angle. Then I need to get rid of this 4. So we have a negative 1 over there. We're going to divide by 3. So cos angle is negative 1/3. Quadrants. Astica. Negative would be for cos here and here. Connected with a reference angle would be there. So I'm going to my calculator, I'm cos inversing, and I'm not going to do negative, so I'm going to do a positive 1/3. Can you see what I typed in? So avoid that negative sign, 70.5. So final answer, where are these located? So 70.5 degrees less than 180. So 109.5. 70.5 degrees bigger than 180 is 250.5 degrees. All right, one last one. You ready? Cos squared of angle plus cos of angle minus 2 equals 0. Okay, so now what do we do? Do you want to think about this if these were x's? Okay, does this look familiar? Simple trinomial. Okay, so simple trinomial means that I'm going to have a cos angle and a cos angle, because that multiplies to my cos squared. These multiply to 2, so I only have one option, 2 and 1, and I need to get a positive 1 out of it. So this is positive and that's negative. Okay, so now, in order for this to be 0, my cos angle would have to equal a negative 2, right? And in order for this to be 0, my cos angle would have to be a positive 1. All right, Astica, cos negative would be here and here. Cos positive would be here and here. Connect those to the x-axis. Okay, this side, cos inverse a positive 2. There's an error. That is correct. There is no solution for this one. Let's see if there's a solution for this one. So I'm going to cos inverse 1, and I get 0 degrees. Okay, so what if I go 0 degrees that way? I'm still at 0 degrees. What if I go 0 degrees backwards? Then I'm still at 360. And there's your final answer. And you can check it out. Should we do 360 as a check? Cos of 360 squared. And then we had plus cos of 360. And then subtract a 2, and we should get 0. So that balances out. Okay, happy equation solving.